So today we're going to continue where we left off on Friday. We're still verifying identities, so if you have your identities worksheet, you probably want to take that out. Not the worksheet, the handout that I gave you with all of the identities on it. So today, one of the new things that we're going to learn is how to use conjugates when we're trying to verify an identity. So we're going to do an example that has a conjugate. So just as a little reminder, if you don't remember what a conjugate is, we did do those in Algebra 2. And so here's an example. You definitely did them when you were studying radicals. So let's say, for example, we have something like, let's just put a 3 in the numerator. Let's say in your denominator you have something like 4 minus radical 5. So we're not allowed to have radicals in the denominator, and so what we did is we did this process called rationalizing, where we multiply by basically the same parentheses except with the opposite sign of what you have in your problem. So the conjugate would be 4 plus radical 5. So notice that the first terms are the same, the last terms are the same, the only difference is the sign. So if this sign were plus, then this one would be minus. So we would do the same thing in both the denominator and the numerator, and then what would happen is you would multiply everything. You would FOIL, do the whole process, and you would find out that you have no more radicals in the denominator. Well, when we're verifying trig identities, we're not seeing radicals, but what we're doing is we're using this idea of multiplying by the same parentheses but with the opposite sign, which is a conjugate. We see that same thing working for us when we're dealing with trig functions. So sometimes you have something like, let me show you, like in the denominator, you might have something like 1 minus sine squared, and you're thinking, oops, I'm sorry, no. You have something like 1 minus sine, and you're thinking, oh, wouldn't it be great if that looked like 1 minus sine squared? Because once you have those squares, you're able to start using the Pythagorean identities. And so one of the ways that you can manipulate this this expression and get that to be a squared is actually by using conjugates. So again, the idea is we're multiplying by almost the same value, except we're changing that sign in the middle. So in this example over here, if I wanted to multiply by the conjugate, I would actually multiply by 1 plus sine squared. And I would end up getting 1 minus sine, and I would end up getting 1 minus sine squared, which is great because that comes from one of the Pythagorean identities. So let's go ahead and take a look. So at any point, if you need to pause this video to write down notes or to rewatch something, obviously feel free to do that, and just make sure you're watching each of the examples because they're each very unique, so you don't want to miss any kind of skills or things that we're using that you can then use on other problems that you encounter. So let's go ahead and do this example. So we have verified the identity. We have secant x plus tangent x equals cosine x all over 1 minus sine x. So to me, the more complex side looks like the right side. And the fact that I just told you about conjugates kind of gives away that we're going to use the right side, because in the denominator we have 1 minus sine x, and wouldn't it be great if it said 1 minus sine squared x? So we're going to go ahead and work with the right side, and what I'm going to do is I'm going to multiply by the conjugate because I do want it to be 1 minus sine squared. So I'm going to rewrite my fraction, and now here's what I'm going to do. I'm going to multiply by 1 plus sine x, the conjugate. Okay. Now what I'm going to do is I'm going to go ahead and multiply everything through. So when I do that, when I multiply cosine times 1, I get cosine. When I multiply cosine times sine, I get cosine sine. And in my denominator, when I multiply all of this out, you might know some of the shortcuts, but you can multiply the whole thing out. But I'll tell you, we end up getting 1 minus sine squared. Okay, so now that we have 1 minus sine squared in the denominator, if you take a look at your Pythagorean identities, you can use the very first one, which is sine squared plus cosine squared equals 1. And what we can do is we can subtract sine squared on both sides, and we'll have exactly what we have in the denominator. So sine squared is equal to, in this exact order, 1 minus sine squared. All right, so this right here is exactly what we have in the denominator. So I'm going to use substitution. Instead of having this long thing, I'm going to rewrite it as just cosine squared. So I'm going to rewrite my numerator. Remember, I know it's tedious to keep rewriting things, but remember this is a proof, so every line counts. We have to make sure that the logic is there. So you don't want to skip steps, actually. You want to be really, really detailed. So I'm going to rewrite this as cosine x plus cosine sine all over cosine squared. All right, so now if we take a look at the beginning of the problem, we're trying to get to something that looks like secant plus tangent. All right, so we're going to have to separate this numerator somehow. Well, we can definitely do that. I can rewrite this as cosine x all over this denominator. So cosine squared x, and then I'll bring down my plus, and I'll rewrite the second part of that numerator over that same denominator. So what I just did is I unsimplified. I separated the fractions, which is kind of odd because normally we always want to simplify, right? Since you've been doing algebra, everything's simplify, simplify, simplify. But now we're actually unsimplifying it because we want to have two separate terms. So I've run out of room here, so I'm going to go ahead and continue up here, but you should really continue on the next line down. Now, cosine x over cosine squared, I know that this cosine and one of my cosines will cancel, so I'm left with 1 over cosine. And then I have plus. Now, this cosine and another one of my cosines cancels, so that leaves me with sine over cosine. And now let's go ahead and start using our identities again. Well, 1 over cosine is secant, and sine over cosine is tangent. All right, and we're done because this matches our original problem. All right, so if I had enough space, I would write secant x plus tangent x equals secant x plus tangent x. All right, so I've run out of room a little bit, but make sure that you do that in your notes. All right, let's keep going. The next example, we have cosecant squared over secant squared equals cosecant squared minus 1. So here, it's kind of, it's not really clear which one's the more complex side. You could argue that the one on the left has 2 parts, but the one on the right has 2 terms. So here it's kind of your own choice. What I'm going to do is, because I recognize this, cosecant squared minus 1, that actually comes from one of the Pythagorean identities, I'm going to start there because I already know how to simplify that. So if you look at your identities sheet, the one that I handed out to you at the very beginning of this, we have the third Pythagorean identity, which says 1 plus cotangent squared equals cosecant squared. And so what I'm going to do is I'm just going to do minus 1 on both sides, and that's going to get me exactly what I have on the right side, which is cosecant squared minus 1. So now I can replace this, I can substitute that with just cotangent. So I'm already simplifying. So that's why I'm going to choose the right side. So I'm going to go ahead and do that. All right, so I'm going to rewrite this as cotangent squared. Now, cotangent squared, again, look ahead and look at what you're trying to get to. We're trying to get to cosecant squared over secant squared, which to me makes sense that I'm starting to think in my brain, I'm starting to think about the connections that that has with sine and cosine. Well, then let me write cotangent squared as cosine squared over sine squared instead of 1 over tangent squared. I don't need a tangent at all in this problem, so I don't want to use that option. The better option is to use cosine squared over sine squared because of the connection that those 2 trig functions have to cosecant and secant, which is what we're trying to get to. So let's keep going. what I like to do once I have that is I like to kind of separate them so I can really take a look at each trig function by itself. So I'm going to separate that fraction. I'm going to make this cosine squared over 1, and then I'm going to separate the bottom, which is technically 1 over sine squared. All right, now when I see it that way, it becomes really clear how we're going to get cosecant and secant. So cosine, if I just reciprocate it, it's 1 over secant, which is what we need. And 1 over sine is cosecant squared over 1. Now when I multiply those two things together, I get cosecant squared over secant squared, and that's exactly what I have on the left-hand side. So we have just proved the identity. All right, let's keep moving along. So now we have this next problem, 1 over sine squared tangent squared equals cosecant times cosecant squared minus 1. Again, this one, you could argue the left side technically has two parts, right? The numerator and denominator, and the right side technically is only one term. Although it looks like multiple things, that multiplication is actually making all of it one term. I'm going to go ahead and choose the right side. I feel like I can get to 1 over sine squared tangent squared much faster than I could get to cosecant squared times cosecant squared minus 1. So I'm going to go ahead and start working on the right side. Well, immediately cosecant squared, if I, again, look ahead and look at what I'm trying to get to, cosecant squared equals 1 over sine squared, which is what I have right here. So I'm going to go ahead and just write it in that way. I'm going to write it as 1 over sine squared. Now, cosine squared minus 1, I'm going to use the Pythagorean identity. So anytime you see a 1 that's being like added or subtracted, your go-to is Pythagorean. It's probably going to come from one of those. Not always, but the majority of the time it will. So if we take a look at the Pythagorean identity that has a 1 and has a cosecant, it's the last one. 1 plus cotangent squared equals cosecant squared. All right, so I need it to say cosecant squared minus 1. So I'm just going to subtract 1, move it around a little bit. So now I have cotangent squared equals cosecant squared minus 1, and that whole thing equals cotangent squared. So I'm going to replace this whole parentheses with cotangent squared, and I can put that over 1. And again, look at what you're trying to get to. I already have my sine squared in the denominator. All I need is a tangent. Well, how do I get a tangent? Cotangent squared is 1 over tangent. So let's write it as its reciprocal. Now I can go ahead and actually multiply the numerators, multiply the denominators. These are just fractions. We don't need common denominators because we're not adding or subtracting. We're multiplying. So I can go ahead and multiply this. 1 times 1 is 1 in the numerator. Sine squared times tangent squared in the denominator is just sine squared, tangent squared. And there we have it. We have verified this identity. All right, let's do a couple more. So here we have something that looks pretty equally complex, but again, I recognize on the right side one of the Pythagorean identities, secant squared minus 1. If you take a look at the second Pythagorean identity, it's 1 plus tangent squared equals secant squared, and I'm going to do minus 1. Now what I have is tangent squared equals secant squared minus 1, which is exactly what I have on the right side. So already I'm finding it pretty simple to simplify. So I'm gonna work on that right side. I'm gonna turn that into tangent squared. All right, now tangent squared, if we take a look at what we're trying to get to, it's secant times sine. So I don't want to use cotangent. I want to use something that has sine and cosine because of the connection that secant and sine have to those two functions. So I'm going to rewrite tangent squared as sine squared over cosine squared. Okay, now again, I'm going to use that trick where I separate it. I'm going to put sine as its own fraction, and I'm going to put cosine as its own fraction, but be careful because cosine is in the denominator. So that's really a 1 over cosine. Now, sine squared, looking back to what I need, what I'm trying to get to, should stay in the numerator, so I'm going to leave it alone. Now, 1 over cosine, another way to write that is secant, right? Those are reciprocals of each other. 1 over cosine is the reciprocal of secant. So I can rewrite 1 over cosine squared as secant squared. And I have in a different order, but I still technically have exactly what I have on the left side. Remember that multiplication is commutative, so I can switch the order around and it doesn't matter. So I have proven and I have verified the identity. Let's try another one, and then I'm going to have you guys try some on your own. So we have 1 minus cosecant squared in the numerator, all over cosine, and we're trying to verify that that equals negative cosecant squared. One more time, I already recognize one of the Pythagorean identities. In the numerator, I have 1 minus cosecant squared. Now, if you take a look at the options under the Pythagorean identities, the identity that has 1 and cosecant is 1 plus cotangent squared equals cosecant squared. Now be careful because the order, especially because it's subtraction, is really important. This one says 1 minus cosecant squared, not cosecant minus 1. Those two are very different identities. So what I'm going to do instead is, since I need my 1 to be first, I'm actually going to subtract cosecant squared so that it's subtracting from the 1. So I have 1 minus cosecant squared plus cotangent equals nothing, so 0. But I want it to just be 1 minus cosecant squared. So I need to get rid of that cotangent. So I'm just going to do minus cotangent squared on both sides. You could have done this in one step too. If you're able to see that and think ahead, you can just do it in one step. Okay, now also keep in mind that all this work that I'm doing right here on the side is not even part of your proof. If you can do that mentally, but correctly do it mentally, then you don't have to show me any of that work. All right, so now I know that 1 minus cosecant, which is my numerator, is equal to negative cotangent squared. Now, let's pause for 1 second. The fact that we have a negative at this point is a good sign because our identity that we're trying to verify is a negative. So we've just introduced a negative, makes it look like we're heading in the right direction. So those are some good things to notice. So let's go ahead and replace the numerator with negative cotangent squared, and all of that is over cosine squared. And let's keep working with that. Now I'm trying to get to negative cosecant squared. So I'm going to do that trick one more time where I separate the fractions. So I have negative cotangent squared over 1 times 1 over cosine squared. Okay. Now negative cotangent can be rewritten as cosine squared over sine squared. It can also be rewritten as 1 over tangent squared, but notice that we're not trying to get to anything with tangent, so let's not use that option. So I'm going to rewrite negative cotangent squared as cosine squared over sine squared. That's still multiplying 1 over cosine squared. And check this out, these cancel. All right, so now I have negative 1 over sine squared, and negative 1 over sine squared equals negative cosecant squared. And that is exactly what we have on the right-hand side. All right, so we have verified this identity. Also keep in mind that the way that I'm showing you is just one of many, many ways. There's so many other ways to arrive at that final identity. So there's not just one way that's correct, although I will say sometimes you can choose a path that takes lines and lines and lines of work that will maybe take you a much longer time than if you had chosen, a different route. And that's important too, because let's say come test time or quiz time, you don't want to spend half an hour on one problem because you chose the long way. You do want to try to choose the fastest way, the most efficient way to verify it. All right, but just keep in mind that there are always multiple ways to do these things. So what I'm going to ask you to do now is I want you to try some on your own. All right, so I'm going to flip through some of the examples that I have here, and you'll have to pause the video, choose one that you want to start with. You should do several. If you can do all of these, that would be ideal. But if you run out of time before the bell rings, then that's okay. I just want to make sure that you are practicing some of these on your own. If you want to, as you're working, quietly check with other people and see if others are getting similar answers to you, that's fine. Everyone's probably going to be paced a little bit differently, so I don't know how well it'll work to work together with some people. We don't want to be too loud because some people might still be watching the video. So I would say work independently, and every now and then just quietly check with one another and see if you're getting the proofs. All right, so there won't be any homework tonight as long as you are working on these throughout the block. All right, and I will see you guys tomorrow. So here are the examples that I'd like you to work through. So I'm going to go ahead and flip through some of them, and you will have to pause as you're working through them.